Hello everyone, my name is Ajay and this is going to do a second part on network load balancer on AWS. So the diagram what you see on my screen, there are users who those are sitting on the internet, basically this area, and then you have a load balancer, and then there's a one subnet which is part of one AG, and we have seen anytime when the traffic comes from the user who those are sitting on the internet and hitting a listener on the load balancer, traffic get distributed to the number of EC2 machines. Basically, those are going to be the part of this subnet. So that worked. And today we are going to do some enhancement in our network topology and see the different behaviors. Now you see a change in the topology. I added on-premise stuff and a VPC which is going to be the paired one. So what can happen when the traffic which comes from the internet and it hits the load balancer, it can be redirected to the subnets. Those are going to be the part of same VPC. It can also be redirected over paired link, and this traffic, it can also be redirected to on-prem. So you have all these options available. So in the first scenario, I'm going to divert this traffic to same VPC, and we are going to see the connection table, how it looks like, what is going to be the impact when you do the IP preservation, and there are other attributes also associated. So we'll see those one by one, and then what will happen when you move this load to paired VPC. Let's quickly take a look on the VPC configuration. So I'm in US East 1, which is going to be the North Virginia. This is my CIDR block, which is 10.10.0.0, and I have got 1/24 subnet from here. There is peering which exists, though I have not shown here. So that peering is between VPC A and VPC B, and I'm going to do the routing. So I'm going to add a route. This subnet 10.20.0 is part of Ohio. So you see a route towards VPC peering. Same thing I need to do on the other side also. So as of now, consider there's a peering exists between both the VPCs. On Ohio side, I have another VPC and the CIDR block is going to be 10.20.0.0. And the same thing I have done, I have got 1/24 from the same range. Keep in mind, you need to do the same routing for a CIDR block which belongs to VPC A from VPC B. So you can see there's a route which is configured towards VPC peering. Now I'm running a EC2 instance which is T2 Micro, and I'm using Windows Server 2012 R2. So we can see the name of this EC2 instance is web-nv. This belongs to US East 1B, that's the AG, and the public IP you can see is 52.203.93.55. You can also verify the private IP address from here or maybe from the console. And I'm going to run a WebSocket. That is the reason I have installed the Python on this machine. So this is the script basically, and it's a WebSocket script written in Python, which opens a port 12345. When you run it, what I can see, a socket is successfully created and that is binded to port 12345 and socket is listening. So it is ready for the test, and the test I'm going to do, I'm going to initiate communication on port 12345 from internet. So when I do it, this is what you see. So you can see this is a request coming from IP 182.70.60.150. So this is the source IP address and this is the source port. And in the browser, you can see the page is not working, error, invalid HTTP response, which is fine. So the reason behind I'm not running any sort of the web page or something like that. It's just a WebSocket. And when I see a lookup for what is my IP.com, I see the same IP address. This is just to test that the EC2 instance, is it listening or not listening on the port what we opened from this WebSocket. Couple of things to keep in mind. Your security group, which is assigned to EC2 instance, that should be opened from internet for this port 12345. And if you're on the Windows machine, please ensure your Windows firewall is not blocking this port. Now I will be creating a load balancer and the listener will be configured for the port 12345, which is going to be the TCP port. And we are going to attach this instance as a part of the target group. While you create the target group, couple of things to keep in mind. If you have your load balancer and the target group which is sitting in the same VPC, you can use this instances option also. However, I'm going to use the IP address, so that is also available. You can choose target IP address. It can be part of the same VPC or it can be on-prem, or maybe the target host is sitting over the VPC. So it can be anywhere. So far you have the connectivity. This works. So you can see I have given the target name TRVPCA. Protocol is going to be the TCP, and I'm going to use a listener port which is going to be the 12345. Now you need to add the IP address, and I'm going to add the IP address which is coming from my instance, which is sitting in US East 1B, and the port is going to be 1234. You can hit create target group. Now we have the target group created and it is not associated. So we need to do this association also on the load balancer side. Now let's do the association. So I'm going to attach this tr-vpca, which is the target group I created, to the load balancer listener. Now we can see the load balancer is active and ready to take the request which should be coming from the internet. So this is the DNS name. I'm going to use it. So a couple of things to notice. Before requesting any request from the internet, from the browser, this is what I see. And these are the hits basically not coming from the internet, but this is coming from the load balancer while doing the health check for the target groups. And this is going to be the IP address which it has taken. And also notice this is the IP address, internal IP address of the load balancer from a subnet 10.10.0.0/24, what we created to host the EC2 instance. And the moment I create, or the moment I basically hit the URL on the port 12345 from the internet, this is the expected error what we have seen when we were hitting the EC2 instance directly. So it means even if you're coming from the load balancer, this application works. And now what do we see? Couple of requests coming from the internal load balancer. Those might be for the health check, and the request which is coming from internet, that is also coming from the internal IP on the load balancer. Now under the target group, I see my instance is healthy. You can go to the attributes and let's focus on the attribute which is going to be preserve client IP address. What it mean? It is disabled by default. And let's see when we make it enabled, what will happen. And the moment I enable it and save the changes, I see it start receiving the request from the internal IP as well as the internet IP address. So internal IP address requests, these are going to be for your health check. However, whenever you see 182.70 series IP address, this is coming from the browser. So the lab was meant to show you how to preserve client IP address. There are some catches When you enable this setting, that means your load balancer and the target pool members, they are supposed to be in the same VPC. If they are not, it is going to break your application. In the another scenario, what I'm going to do, I'm basically going to stop this instance and move this instance to VPCB, where you have a peering which is already established. It means this load balancer here, it can talk to instances from your peering connection. So you can see my screen, this instance is stopped. So I do not have any EC2 instance which is running a part of the VPCA. And when you spin this instance, these are the IP addresses I see. So private IP address going to be 10.20.0.80 and the public IP is going to be 3.128.170.132. So my EC2 instance, it is running in a VPCV. Let's try to test the connectivity from internet directly. So you can see the IP address is going to be 0.80 and this EC2 instance, it is listening on port 12345, very similar to what we had on VPCA. And when I start hitting it from the internet on port 12345, I see this is the expected result and I see the IP address coming from my browser. That's the IP address which is assigned to me. Now let's try to add or modify our target group. So this was the host which was basically registered earlier. Since I stopped it, so we can see the status it is unhealthy. So now what you need to do, you need to deregister it from here and add another host which is going to be 10.20.0.80. Now there's a catch. Since this is outside of the VPC range, you need to choose this option, other private IP address. Port is going to be the same, 12345, and make sure you have Windows Firewall disabled and security group is allowing this port 12345 on the instance where it is mapped. Now we see the first host which we deregistered, the health status is training, and the new host which we added, it is in initial state. Now this host, it becomes healthy. That means it is ready to receive the traffic from the load balancer. And here, what I see, all the requests which is basically coming from the load balancer, it is using the private IP address. And I have not disabled IP preservation. So when I test it from the browser, this is not going to work. And all these hits, what you see, this is just for the health check. So to make it work, what I need to do, I just need to uncheck these settings. Since this is not supported over the paired IP address, and that is expected also. If I pass the public IP address to that particular VPC, what will happen? It will take the default route and it will go out. When the connection is sourced from the private IP address of the load balancer, so the reply will come back to that also. So what I mean to say, if I say this is my load balancer, it is hitting a EC2 instance which is in paired connection or over the paired connection. And I have a connectivity from this subnet, this is a VPC A, this is going to be the VPC B. So any request which hits this load balancer from outside, and when this connection is passed over the EC2, it will take the private IP address basically, which is configured on the LB. So that when this EC2 respond back, that response comes back to load balancer. So to make it work, as I said, you need to disable it. And then we see lot many requests, it is flowing. And this time also I'm going to see the IP address, which is going to be the internal IP address of the load balancer, whether it's going to be the health check or it is going to be a connection which is coming from the browser from the internet. So basically, when this IP preservation it is disabled, I see all the requests coming in, and when this setting is enabled, what I see, I'm not able to reach the application. It's broken. There is one more feature called which is cross-zone load balancing. As I mentioned earlier, the moment you add more AGs, it is going to launch a separate instance for those AGs. So for example, this is AG1, this is the load balancer. For AG2, this is a load balancer. And without enabling cross-zone load balancing on, how it works. So I'm getting two requests coming from internet in red. If they hit this load balancer, they are only going to be distributed here in AG1. Similarly, if I get two more requests in blue, those are going to be distributed here. And the moment I enable the cross-zone load balancing, see what happens. It can load balance across AGs. So if two requests are coming, one can hit this, another one can go from this load balancer to this AG. Similarly, if these are two requests, one can hit this EC2 instance and another one can go to AG1. And to make it work also, please ensure your IP preservation it is disabled. Thank you for watching and I will see you in the next video.